In this video, we will solve a simplified version of the wave sorting problem from Code Wars. Take a moment to read and understand the problem. I will pause the video. In the process of solving this problem, we will also learn a couple of common problem solving strategies that you can also apply to other problems. Okay, so here's an example of an input and the corresponding output. You can also think of this input as the initial state and the output as the final state of the program. So as you can see here, you can notice that the value of each element in the array initially decreases and then increases in alternating fashion as we move through the array. So the value decreases here and increases here, decreases again, and so on. So we have to write a program which takes an arbitrary array and returns a new array which follows this pattern. And there is not just one solution to this problem, there are many solutions. For example, we can interchange the 2 and 1 here. So I'll place the 1 first and then 2 later, and this is also a valid solution. But in our case, it is sufficient if we provide just one valid solution. And also I mentioned that we'll be solving a simplified version of the problem. So we'll be assuming that all the values are unique. And the exercise for you is to solve the original problem where the values need not be unique. Okay. So how do we solve this problem? One of the first ways to solve the problem is to generate all the combinations, or rather all the permutations, right? Let's assume that this was the original example, 5 4 3 7 8. What you can do is just generate all the permutations, so things like 3 4 7 8 5, and then 5 8 7 5 8 7 4 3, and so on, right? If there are 5 numbers in the array, you'll have 5 factorial ways of arranging these elements, and we can just pick any one which matches our desired pattern, right? This is like the brute force way to solve the problem. But is there a better way? I'll pause the video, think about it, and then we'll continue. Okay, so one of the common strategies is to sort the input, right? So sorting is usually used as a pre-processing step. That means like a step that we do before we solve our original problem, just to make it easier for us to solve that problem. So let's just try and see if it works. Keep in mind, this is speculative, so this may or may not work. If sorting the input helps us, then fantastic. If not, we'll have to go back and come up with a different strategy. Okay, we have this array here, and we will sort it. Now the array is 3 4 5 7 8, and now does it help us solve the problem? Okay, one strategy is called as a working backward strategy. So we'll apply this strategy to solve this problem. So in this strategy, what we do is we assume that we are already in the middle of the program and we have made good progress so far. And then we'll ask ourselves, what is the desired state that we want the program to be in the middle of the program? And then see if we can continue to maintain that desired state. So I hope you have watched the video on state. If you have watched it, I'm sure it will help you understand this concept better. If not, go back and watch that video. So yeah, so we'll apply the working backward strategy, and we'll assume that we have already seen the first 3 values in our array. So what is the actual desired state? So one desired state is this arrangement, 4, 3, and 5. So you can see the value decreases initially and then it increases. So now you can assume that you already completed like 3 iterations of our program. We don't know what we are going to do, but let's just assume that you have somehow reached here. And this is the state of the program. It looks fine. And now we are seeing a new value, 7. And now we can focus only on what we will do if we see this new value 7 and we are already in this state. So what can we do to maintain this state? Well, one thing we can try is, what if we just add the 7 at the end? Will it continue to work? Well, no, because we now have two values that are increasing consecutively. So this does not follow the desired pattern. So what can we do? Well, you can think about it and then realize that, we have sort of already partially solved our problem, right? So just because we see a new value, we don't have to change all the values that we have so far. So what we can do is, all we have to do is just exchange this 7 with 5. And now once again, we are following the pattern. So this is the overall strategy. All this was possible because we applied this working backwards strategy, and you can use it in a lot of different programs. Okay, so now we kind of have a decent idea. Now let's add more and more values and see what are the different cases we need to handle. Now we see the new value 8. Okay, once again we can check whether we can just append 8 to this list and see if the pattern holds. So we have 4, 3, 7, 5 and 8. So in this case the pattern holds. Initially the value decreases, now it increases, and you can see that the remaining values are unaffected. And great, we are moving in the right direction. In this case we did not have to exchange the two values. Alright, now let's extend the program. Let's add a new value. Now if we see 9, then can we just directly add it? Let's see, we are adding 9 here, but in this case once you can see that we have 3 values in ascending order, so we need to exchange it. Okay, so we can try a couple more examples and finally identify our strategy. So now that you have seen 3 or 4 different new values that were added, we found a general strategy. So the strategy is, we just have to compare the two previous values we have seen so far. If they are in increasing order, like here, then we have to exchange the new value with the last seen value. So we have to exchange. On the other hand, if we have two values and at the end and they're already in decreasing order, then we just have to add the new value. All this works because our array is sorted and each new value is greater than the previous value. So overall, this is how we figured out the strategy. Now we have to come up with a pseudocode to represent this strategy. So let's do that. But before we do that, one thing we have to remember is, so far we only we have assumed that we are already in a good shape, right? We assume that these 3 values were already in good state, and then we figure out the logic for the general case. But how do we initialize the state, right? How do we manage the first 2 values? So that is another thing we have to think about. For that, once again, there's a simple approach. Now that our array is sorted, all we have to do is exchange the first 2 values. We just have to exchange 4 with 3, and we have this. And now we can continue with the next value onwards and apply our strategy. Cool. So you can try it with a couple of examples and make sure that this logic works. Now we have to write the pseudocode. That's fairly simple. Let's see the pseudocode. The first step is to sort the array. The next step is to swap array of 0 with array of 1 so that we can kickstart the wave sorting process. Now for I from 2 to the end of the array, we just have to check whether the last 2 values are increasing, whether array of I minus 1 is greater than array of I minus 2. If so, then we just have to swap the new value with the previous value. That's it. This is our strategy. So the code itself is like quite simple, isn't it? It's almost as simple as finding like the maximum value in an array. On the other hand, it took us quite some time to get the logic. Of course, there could be other strategies as well, but this is one such strategy. So in this particular case, coming up with a strategy was difficult, right? And the code itself is simple. Okay, now that we have the code, we can write the, now that we have the pseudocode, we can convert it into actual code. So let's not write it from scratch. We already have the expected program here. You can notice in the pseudocode that we swapped two values in two different places, right? So we can extract out a helper function. We can just write a function swap which will swap both uh, two random values in an array. So this is the code for that. This will help us because that way our actual code will match the pseudocode very closely and chances of going wrong is quite less. And of course we can handle some edge cases, and we'll sort the array, then we'll swap the first two values, then we'll loop through all the values and check whether array of I minus 1 is greater than array of minus 2. If so, we have to swap these two values. If not, then great, we don't have to do anything. In fact, we can even remove this condition. Let's run our code. Here, this is our input. We have like bunch of values in arbitrary order, and let's just check how it works. So we run our code, and at the start of the first iteration our I value is 2 and all the values we have seen so far is 102, and at the end of the iteration the value is still 102, and in the next iteration we can see that we need to swap the two values. So at the end of the iteration the value of the array has changed, and in the next iteration we don't have to swap, and now we need to swap the two variables again, swap 4 and 5. So the program progresses this way until we reach the final state, and this is the expected output where you can see that the wave pattern is maintained. Awesome. So to summarize, we learned that sorting is a good pre-processing step. You can see if it works. If not, you can always try something else. And the next thing is we can utilize our awareness of the state of the algorithm and use that to work backwards. So working backwards is also a very common strategy, and you can use it to figure out the logic initially when you don't have a good idea on how to solve the problem. And now the exercise. What if the values are not unique, right? So go ahead and solve the original problem. The clue is you may need to come up with a new strategy, but you can still use this working backward approach.